On behalf of the National Academy of Sciences India, NASI, the oldest science academy of this country, in fact, also the largest science academy of the country. The academy was founded in 1930 by Professor Meghnad Saha, a great patriot and the then professor of physics, University of Allahabad. Almost, we don't want to go in detail of the history of NASI, but we know that from its inception, NASI envisions the cultivation and promotion of science and technology in all its branches through promoting scientific and technological research related to the problems of societal welfare. So, under the mandate of Science and Society, the Academy organizes several programs throughout the year with the help of its 23 local chapters spread all over the country. Academy headquarters. Hello, sir, may I audible, sir?
Yeah, you are audible.
Yeah, the Academy headquarters and its chapters, almost all the chapters, celebrate so many national and international days like National Technology Day, National Science Day, and International Women Day, Earth Day, and so many days. The purpose of celebrating such days or events are to educate the general public on issues of concern and resources to address the national or global problems, and also to reinforce achievements of humanity. Today, we are celebrating 47th anniversary of World Environment Day. As I said earlier, the main aim is to raise awareness about emerging environmental issues. On the auspicious of World Environment Day, this webinar has been organized on the theme Water Quality, Purification and Preservation. This program is to initiate the NASI's water program under the NASI New Initiative, chaired by Honorable Professor Manju Sharma Madam, and it is coordinated by Professor P.K.Seth sir. Professor Seth sir is the coordinator of this program, is the former director of Indian Institute of Toxicological Research and former CEO Biotech Park, Lucknow. Professor Seth sir is associated with the academy almost more than 40 years and having as the vice president of this academy, general secretary and chairman of several committees of the NASI. May I request Professor Seth sir to kindly welcome the guest and also describe the genesis of this webinar. Respected Professor Seth sir.
Thank you, Dr. Santosh Shukla, and I'm really grateful to having this opportunity on this very auspicious day, and greetings to all on the World Environment Day. Professor Ghatak, our President, Dr. Manju Sharma, Madam, who is the chair of the new initiatives of the NASI program, and distinguished women scientists of DST, our two very prominent speakers who are going to be there, Dr. T. Pradeep, Professor Pradeep, Dr. Tiwari, and Professor Satyadevji, the General Secretary, and headquarters, Dr. Paranjit Khurana, General Secretary, I see Dr. Pramod Tandon, Dr. Veena Tandon, Dr. Chandrima Shah, Dr. V.P. Kamboj, our past president, and many scientists and who are associated with the academy and attending this webinar. I have been given this opportunity to give the genesis. When I go for the genesis, I am reminded of late Dr. V.P. Sharma. He was the main architect of the water safety and water security program, and he was very deeply committed and concerned with the water issues which the whole society was facing. And I'm reminded that under his guidance, how this program, water program, progressed with the greatest speed. And I remember the occasion of the Platinum Jubilee function of the NASI held at Allahabad in October 6 on 2005, when Dr. Kalam, the president, released the booklet on the safe water health for success. That was for the program, for the children's program. This was released on that occasion at Allahabad, and also recall the very meticulously planned, along with Professor K.J. Nath, the National Symposium on Drinking Water and Community Health, Standards, Surveillance, and management, which was held at INSA in February. That was again a very successful, and based on the proceedings of the symposium, and the book was brought out. That was the Safe Water for Community Health, and with Dr. K.J. The following of this was again with the brainstorming sessions held sequentially in 2009, 2012, 14, and 17, and then finally in 2019. In all these 2009, 12, 14, Dr. Sharma brought out the books based on the recommendations made, based on the proceedings, and also 2017, which unfortunately when we lost him, and this was again brought out the book, again edited by him and Dr. K.J. The proceedings, all as I mentioned, were published in the book, and whenever he was requested to participate in a program, maybe it may be a job while, maybe just a simple interaction with the students on water issues, he was always eager to come forward and give his time, deliberate with the children, deliberate with the scientists, and the, uh, the society. I may just add that this country has been facing acute water crisis, and this is about 600 million people face high to extreme water stress, and it is estimated that according to the WHO, that about 2 lakh people die every year due to inadequate access to water, and about 75% households do not have drinking water in premises in rural areas. 80% households do not have piped water access. Of the available waters, 75% is contaminated with chemicals, microorganisms. In the ranking, India ranks very low. Among the 122 countries, it is at 120. And this is with respect to the water quality. Now, thanks to the efforts taken up by the various regulatory agencies, there have been a significant reduction in the chemical contamination of water. However, due to climate change and significant extraction of water from ground in an unplanned manner, the groundwater in certain pockets of the is contaminated, and it is mostly due to the anthropogenic sources. For example, the activities of extracting the water has led to the arsenic and fluoride issues. The groundwater with the arsenic contamination is increasing, and now, besides West Bengal, states of UP, Bihar, Jharkhand, and Assam and Tripura are also exhibiting significant levels of arsenic in groundwater. NITI Aayog has announced that the government has taken significant steps to provide piped water in villages and chalked out a time-bound program. This will certainly ease the water problem to a great extent in coming years and safeguard the health of the people. To monitor the water program, NITI Aayog has set up a composite water management index, a native tool for water measurement, management and improvement. Already, based on these studies through these tools, some states are showing improvement, but we have a long way to go. It is true that certain areas in different states, either due to industrial activity, that is discharge of wastewater into the river or ponds, the quality of the surface water is not fit for drinking. People who are solely living on the contaminated surface water are facing severe health risks. As I said, that in the villages, the pipe water is not available and people are dependent on the surface water. And the surface water, as it's contaminated, it leads to a number of the risks. The challenge today is to find technologies for removal of the contaminants, that is purification of water, and make it fit for drinking so that people's health could be saved. The technology should be affordable and meet the need of the poorest of the poor. Also, the challenge is to manage the groundwater, that is recharging the receding groundwater levels, reviving old water resources, and finding new resources of water, again using newer technologies. NASI has revolved Baulis in Madhya Pradesh under the direction and supervision of the late Dr. P.K. Sharma, and during this Bhopal meeting, these Baulis were inaugurated and dedicated to him. Today, we have two distinguished scientists of the country who will be dwelling upon these challenges which I just mentioned. Professor T. Pradeep, who is the Institute Professor, Indian Institute of Technology, Madras, Chennai, and also he is the Deepak Parekh Institute Chair Professor at that same institute, will be talking about the status of the nanochemistry-based technologies for removal of pesticides, arsenic, and other toxic chemicals of water. The other speaker, Dr. B.M. Tiwari, who is the director of CSR NGRI, that is the National Geophysiological Research Institute, Hyderabad, who has earlier been the director of National Center for Earth Sciences Studies under the Ministry of Earth Sciences at Thiruvananthapuram. He will be dwelling upon the challenges of the water management, particularly the groundwater, and suggesting management plans for quantity and quality through contrasting case studies. I am grateful to both of the speakers for accepting our request, and in spite of the several engagements and the commitments which they both have, but I'm really grateful to them for agreeing to be a part to speak on this occasion and let us know about the studies which are going on for providing the safe water and making water accessible through the new technologies and through new models. Thank you very much for this opportunity.
Thank
Santosh,
you very
over
much.
to you.
Thank you very much, sir, for lighting us for this journey and future programs the NASI will have. And we are very much assured that the NASI water program will be move a flagship program in future also. Now I request Professor Manju Sharma Madam, Padma Bhushan Professor Manju Sharma Madam doesn't need any introduction in the scientific fraternity. Madam is not only the role model of women scientists, also the icon for us. The academies feel proud and also grateful to Madam for her immense contribution to the development and guidance to the academy for more than almost 40 years. As the chairperson of NASI New Initiatives, Madam has guided and developed so many flagship programs of NASI as the NASI Tribal Program, Jagrukta Abhiyan, NASI Nutrition Programs, Women Program, and much more. So may I request Honorable Manju Sharma Madam to kindly say a few words as a blessings on this special occasion, Madam.
Namaskar to all the very distinguished speakers, scientists who are participating in this program, and heartfelt greetings on the World Environment Day to all of you. President INSA is also here, Dr. Chandrima Shaha, our president is also here, and also very, very distinguished people are here. The founder of National Academy of Sciences, India, gave the mandate to the National Academy, Science and Society, which is very relevant to the theme of this particular webinar, because water is meant for the society, and water can only be available when we are using scientific methods. Professor Meghnad Saha, and it's a very famous quote, all of you must have heard several times from me, and all of you must have also read it in the academy. He said, an academy of science can do a great deal by educating public opinion, undertaking particular problems, and bringing out scientific workers in various fields for discussion and cooperative research. But the main function of the academy should be towards cultural improvement by contributions to human knowledge. So all the things which the founder said are very relevant for the present webinar. We are having we are discussing a particular problem. We are having a cooperative discussion. So many scientists are involved from various academies, various institutions, and also to a great extent, water connects us to the cultural problem. Without that, understanding the culture of the people, we will not be able to solve the problem of water in this country. I have been asked to give a recap of the NASI new initiatives, and what I think Santosh has already said, under the science communication program, NASI has developed very special programs for different categories of people in the country, in the society. For women, for defense personnel, for the scheduled caste, scheduled tribes, for students, and for villagers, reaching up to the grassroots level as well as the topmost level, urban, semi-urban, and rural areas. All these programs which I have mentioned, the women program, almost 32 webinars we have held. Defense personnel, we have organized this for the defense personnel all over the country. And STSC program, it's a very widespread program with 25 research institutions involved in this program. For young students, villagers, the rural chopals of NASI have become very famous because they have been able to reach the message of science and technology to the rural people, to the population in villages, and it has become a very successful program. We feel that there is a very good reception on part of the rural population for these. Very recently, last year, during the pandemic, when the Honorable Prime Minister wanted a program on Jagrukta Abhiyan, that was in October, 20th October, and then in September, he said it should be observed as a Poshan Maha, and nutrition being very, very important for prevention of the pandemic and the COVID-19. So both these were announced by the Prime Minister, and NASI took the initiative and organized several webinars on these two subjects. About 23 webinars on the Jagrukta Abhiyan and more than 9 webinars on the nutrition. And in both these webinars, as we have today, the scientists, very eminent scientists, subject area specialists, those who are dealing with the societal aspects of science, those who are dealing with hardcore science, that is the laboratory research, all a combination of high-level science, science which is relevant to the rural population, to the people of the country. All these people were present in these webinars. Very recently, just about 2 weeks ago, NASI has started a very important program with the Indian Council of Medical Research, a NASI ICMR program on the Jagrukta Abhiyan, COVID-19 and appropriate behavior. Now, this particular program is going to be launched in 4 states of the country to begin with, first 3 months, and we have identified coordinators for each one of the areas. Like for Rajasthan, we have Dr. Kiran Katoj. For UP, we have Dr. Manavendra Tripathi. Like that, we have got for Karnataka, Dr. S.L. Hooty, all those people we have identified very carefully who have actually gone in the field and worked with the rural population. So all these people are preparing now, finalizing rather, a very elaborate program for reaching the rural people. And we are going to use the local languages, we are going to use the videos, we are going to use the films and pictorial presentation, all sorts of things. All the medium will be used, including a very important article which came out from the Indian Council of Medical Research. I don't know how many of you have seen in the ICMR latest issue. It is by Balram Bhargav and his colleagues. And this is on practice of face mask. And this article, you'll be very happy to note that it has been translated in 6 languages already. And we are going to use these articles in local languages and give it to the rural people, those at least who can read. And it gives clearly the importance of face masks, even when you are vaccinated. Then also, even if you have had a COVID, for at least next 1 year, you have to wear the mask. And that is one great source of protection, along with, of course, social distancing and washing of hands, etc. So this is a very important program which under the new initiative NASI has launched. And then there is a program with the Department of Biotechnology, NASI DBT program on Poshan. We already have 2 centers, one at Varanasi, all the 3 villages of the Prime Minister, and also one in Dehradun, HESCO is doing it. And these are for the Poshan. And again here, the teams of HESCO and the teams of BHU under the supervision of Professor Madhulika Agarwal are going to the actual villages and working out on the nutrition front. And this program has become extremely popular in the villages of Varanasi as well as Uttarakhand. So these are some of the new initiatives program which NASI has taken up. And what is very important to note here is that NASI's programs are not just meant for one strata of the society, but they go to the upper level, that is the first strata, the educated, the scientist, then the semi-urban, and then it comes down to rural areas. And we are using the children as a medium, and lots of poems and videos have been prepared using the children who are going to give talk about these programs to their parents about the importance of face mask, also about the importance of vaccination. There is a lot of vaccine hesitancy in this country, and we have to overcome that. We want to go to the rural people, explain to them how important the vaccines are for the prevention of COVID-19. So the program is very well spread out in the country. Coming to the World Environment Day, the World Environment Day, today's 2021, is talking about restoring ecosystem and raising awareness. Exactly what we are doing. Professor Dr. P.K.Seth has organized this very relevant and very important webinar, going to the people and spreading the message, creating awareness about the restoration of the ecosystem. That's one of the main aim of the World Environment Day. World Environment Day was started in 1972 when there was an assembly in Stockholm on human and environment, and our former Prime Minister Mrs. Indira Gandhi had gone there to attend on behalf of the country. And in that, it was a decision of all the countries present there that we are going to have a World Environment Day celebration on a particular day, that is 5th of June. And all over the world, everybody has to understand the importance of its ecosystem, the importance of sustainable development, and also preservation of biodiversity, one of the most important objectives of the World Environment Day program. This year's Environment Day program is so relevant to our webinar, Dr. Seth. It is reimagine, recreate, and restore. Reimagine, recreate, and restore. And we are all very happy to know that government is doing a lot in this direction. As was mentioned by Dr. Seth, the Niti Aayog is doing, and Honorable Prime Minister has already released a report of an expert committee on the roadmap for ethanol blending in India, 2020-2025. Again, a very important subject. And you know, the Prime Minister has been talking about the bioenergy, the renewable energy sources, and he's very keen that we move on to this as quickly as possible and avoid using the fossil fuels. So there are several other programs of the government which have been launched on the World Environment Day today, and I am very happy that NASI has always been celebrating for years. We have been celebrating the World Environment Day. We have had lectures on very important subjects which are relevant to environment, biodiversity conservation, and one important thing which NASI took up as a part of the environment protection was the setting up of these galleries for the river systems. And the first gallery, Ganga Gallery, was established in Prayagraj, which is the most unique feature of NASI. No other academy, no other institution has ever established a river system gallery like this, which depicts the scientific, cultural, and religious aspects of the river. And that makes it very attractive for the students, for the tourists. And Santosh will tell us that in Allahabad, whenever there is a tourist mela like Kumbh Mela or Magh Mela, the Ganga Gallery becomes the great attraction for the tourists to come. And similarly, we have established a gallery in Assam, Brahmaputra Gallery, that again has become extremely important. It's just 10 minutes from the airport, and therefore tourists, when they come, the first thing they see, big signboard of Brahmaputra Gallery, and they enter the gallery and they go and see. And again, the gallery depicts everything, the history of origin of river, its tributaries, what is the type of occupation it has generated on the shores of the river, everything about the river. Same thing we have done in Kaveri River in Mysore. So NASI's this initiative is very similar, very close to Dr. Seth's subject of water, which he is now dealing with for the last 2-3 years. We had a very good workshop rather in Bhopal on the same subject, discussing the conservation of water. And now today, in the context of COVID-19, we all know that water has become extremely important, extremely relevant for the population. When we talk of cleaning the hands, we need water. If there is no water in the villages or in the semi-urban areas or even in the urban areas, how will we clean the water? And the advice of the doctors is at least 8 to 10 times in a day, we must wash our hands with soap. That's one very critical issue. Second thing, the drinking water. Drinking water, clean drinking water. That is one of the main stay of COVID-19 prevention and control. Now, when the black fungus is spreading, people are talking that you have to be very careful about the sanitation around, and that again comes to water. So, in all respects, I'm not going to dwell on the water aspect too much in the today, because there are very good experts I see who are going to talk about water. But it is so important, and therefore I connect this water to NASI's new initiative program, which is safe drinking water, protection, prevention, storage, and what the theme of the World Environment Day is: reimagine, recreate, and restore. One has talked about the storing the rainwater, which is very important in today's context, because there is so much shortage of water, and that I'm sure will be talked about by the experts here. So I conclude by saying that, my dear colleagues, we all have to remember that the natural resources of this country are very vast and they are diverse. We have biodiversity, we have water resources, we have streams of river, everything. But we have to be very careful not to consume all of it. Otherwise, what will our future generation, the children, do if we consume all of it? Therefore, the sustainable, judicious utilization of the natural resources is the message which all of us need to take home on the World Environment Day. Thank you very much.
Thank you very much, madam, and for your kind words, and almost your visionary leadership and Bhagirath efforts can't be explained in such very few times. And you have given under your visionary leadership, as well as in the chairperson of the NASI New Initiatives, much more programs are also under the pipeline, as you told about the NASI ICMR programs and many much more. We are looking forward for your kind blessings and guidance in future also, madam. Thank you very much. In the continuation of this program, may I further request Professor Ajay Ghatak sir. Professor Ghatak sir is our Honorable President of this Academy, and he is the pioneer name in the field of research on photonics, fiber optics, and education in India. His name is he has written more than 20 books on that. His textbooks are the Bible or the textbook of the undergraduate and PG students on physics, especially on optics. These books are so popular that many of them has been translated in the Chinese and Russian. Ghatak sir's research on the fiber optics, more than 170 research publication, has opened new horizon of science. So may I request Honorable President sir to kindly deliver his presidential address on this occasion. Professor Ghatak sir.
Can you hear me?
Yes sir, yes sir.
Can you see my slides?
Sir, but it is in very, not in full screen mode, sir.
Can you see now?
Yeah, yes sir, yes sir.
Yes. Thank you, Santosh. Thank you, Mr. Seth, for organizing this event. On behalf of NASI, I welcome you all. First, congratulate you for this World Environment Day and welcome you all to this very important webinar on water quality, water purification, and water preservation. I am not an expert on water. Nevertheless, that I thought I would highlight a few issues only to those people who are not experts on water. For people who are dealing with water, everything is known. Even to the general public, it is known. But I want to re-emphasize the importance of study of water. It is, as we all know, it is the most important thing for life. Our life was created because of water. and our life totally depends on water. But the water which we drink, unimaginable amounts of pollutants and industrial wastes in Yamuna. This is in Delhi. And as the title of that website says, Yamuna is gasping for life. And this photo of Yamuna River in Delhi, taken in November 2016, will make your heart sink. Delhi is said to be the nation's capital, to be one of the most polluted cities in the world. Nevertheless, when the lockdown came, this photo was taken on 4th of April 2020. We had very clear skies, blue skies, and very clear, clean Yamuna. So these pollution in the river is because of wastes from the industry and also created by human beings. Then we have this another very important problem with water today is this groundwater contamination, and we are going to hear a lecture on that. At many places, I will just mention one of the issues. At many places in West Bengal, we have groundwater arsenic contamination. And here, this is a map of West Bengal, and this is the region, the red region of West Bengal, where the arsenic content is more than 50 micrograms per liter. And that causes havoc in the area. And even in the adjacent Bangladesh, it's a very major problem. Arsenic poisoning due to groundwater contamination leads to tremendous skin problems, skin-related problems, as most of you would know. And these symptoms that are developed from drinking of arsenic-contaminated water in villages of West Bengal. So it's one of the most major issues that faces our country. Unacceptably high arsenic concentration in groundwater is not something unique and has been reported in many other countries, including United States. But never have the magnitude of crisis and the resulting tragedy been comparable to what are being witnessed in the Indian subcontinent. So this is a matter of tremendous concerns for all citizens. And this article came out by an author who works in the United States. And then we have rainwater problems, issues regarding, and we can go on. There are so many issues regarding water and water harvesting and so on. So therefore, I cannot overemphasize the importance of studies on water quality, water purification, and water preservation, which is the theme of today's webinar. I must mention, as was mentioned by Dr. Manju Sharma and Dr. Seth, that in the past, numerous initiatives have been taken by NASI. There have been many brainstorming sessions on safe water, and that was spearheaded by our Dr. V.P. Sharma, who played an extremely important role in such sessions. And then, as was mentioned by Dr. Manju Sharma, that our past president, Dr. Abdul Kalam, launched the Safe Water campaign at the Platinum Jubilee celebration of NASI on October 6, 2005 at Allahabad, which is now known as Prayagraj. And this is part of the NASI symposium on safe water. You have Dr. V.P. Sharma, Dr. Swaminathan, Professor Menon, Dr. Kamboj, Dr. Manju Sharma, Dr. Seth, and Professor Menon. And then Professor V.P. Sharma also initiated a large number of Jal Chowpals. And one of them was at Shakargarh in Allahabad, which was also part of the activities of NASI. And he played a very important role in those Chowpals. And then there was water workshops at Satna, Madhya Pradesh, and many other such workshops that were organized by NASI. And one of the very important projects that was initiated by Professor V.P. Sharma was the rejuvenation of abandoned gullies in Madhya Pradesh. It was totally sponsored by NASI. This is the top image is before rejuvenation, and the bottom image is after rejuvenation. as a recognition of that effort. There is a slab there, which is dedication of rejuvenated Baulis to the society. And I'm sure all of you can read this. Below the Rashtriya Vigyanak National NASI, it is written Mridu Jal Sanrakshan Evam Upayog Hetu Academy Dwara Bauliyon Ka Jinodhar. So that is the most important thing. And then the name of Professor V.P. Sharma. So then large number of books, and Professor, in addition to Professor V.P. Sharma, there was tremendous contributions made by Professor K.J. Nath on safe water, and large number of publications were also put forward by NASI. And then, as Dr. Manju Sharma mentioned, we have these river galleries, which are really an education by itself. So we have this, I could get the photograph of Ganga Gallery at Nasi Prayagraj, in which thousands of students visit every year. So finally, we are very grateful to Dr. P.K.Seth, who is coordinating this important program under the umbrella of the New Initiative program, under the leadership of Dr. Manju Sharma and Dr. Alok Dhawan, and to our speakers today, Dr. Pradeep, Dr. Tiwari, Dr. Paramjit Khurana, and Dr. Satyadev. And finally, all this could not have happened without the support of Neeraj and our Santosh at the NASI headquarters in Allahabad. Thank you.
Thank you very much, sir. Thank you very much. And so excellent and illustrated all the journey of NASI water programs. And sir, you very rightly said that the life exists by this water. Not water, when we say five element of our life exist, fire, water, air, earth, and akash. But sir, all these five elements are evolved from each other, one of them each other. I am not going to detail about, but these among these five elements, specific element, the whole universe has been created by these elements. So now very many thanks to you, sir, for sparing your time, and very in short notice you have made such a illustrative PowerPoint, sir. So on the continuation of this program, now I move forward and request to Professor Alok Dhawan, sir, who is an experienced director with leadership in institution building, like many more, founder director of Institute of Life Sciences, Ahmedabad, director of Indian Institute of Toxicology Research, Lucknow, and presently as the director of Center of Biomedical Research, CBMR, Lucknow. Sir, associated with the NASI water program for last many years. May I request you, sir, to kindly give your remarks as well as invite the speakers, sir. Mr. Alok Dhawan, sir.
Thank you so much, Santosh. And at the outset, let me convey my greetings to all of you on this World Environment Day. And if I am permitted, विश्व पर्यावरण दिवस पे आप सबको हमारी शुभकामनाएं, बधाई। पर्यावरण जब बोलते हैं तब हम लोग को समझ में आता है, मैं समझता हूँ एनवायरमेंट जब तक कहते रहते हैं समझ में नहीं आता है, भाव नहीं आता है। तो जब तक हम अपने आवरण को, पर्यावरण को नहीं समझेंगे, हम समझते हैं एनवायरमेंट के साथ हम जस्टिस नहीं कर पाएंगे। मैं सर्वप्रथम प्रोफेसर मंजू शर्मा को अपना नमन करता हूं, जिन्होंने इस प्रोग्राम को सोचा, उसकी संरचना करी, उसको यहाँ तक लेके आए। प्रोफेसर P.K.Seth, who I think, if I may say, because I'm a PhD student, has the knack of organizing things. I think he knows how to get things done within a very short span of time. And I very distinctly remember that I got a call from him saying, "Alok, you know, everything has been finalized, and we have to organize a program within a short span of time. So how about we discuss on the telephone whom we should invite?" And the two names that came to my mind immediately were Pradeep and Prof. Tiwari. And I thought, sir, give me some time, let me call them and see if they are available. And then at least that should be the starting point, apart from other discussions that happen. So I think this is how we need to ensure that the people who are at the top of the pyramid in terms of the work that they do, make us aware, like Professor Manju Sharma was saying, make us aware of what is there in terms of science and technology in this country and how it is benefiting the masses. I'm very grateful to the President NASI, Professor Ghatak, for highlighting the various initiatives that have been taken by NASI. And of course, I'm grateful to the President of INSA, Professor Chandrima Saha, who has been very graciously present today to give us her points of view at some point in time. And also grateful that very senior members, Professor Kamboj, Professor Pramod Tandon, and others are present today. I think I was just thinking when Professor Manju Sharma was talking about what NASI has been doing and when Professor Ghatak was making a presentation. If I just move out a little bit, you can see restore, recreate, and reimagine. I think it was very well mentioned what NASI has been doing. It has restored the Baolis. It has recreated spaces in the NASI and elsewhere where people can be aware, and it has reimagined beyond what was the mandate of the academy, and it has gone to the masses and ensured that they get benefit out of the science that is being done in this country. And if you reimagine a little bit more about this logo of this year's World Environment Day, it looks more like a Ganesha or a little bit like what I would say like Shankar, So with this few words, I would like to introduce the first speaker, Professor Thalapal Pradeep, who's an institute professor at IIT Madras, very dear friend indeed, and he's an author of over 500 scientific papers, but more importantly, an inventor of more than 125 patents or patent applications. His pesticide removal technology, which he developed at IIT Madras, has now reached to more than 10 million people. His arsenic removal technology has reached to more than 1.2 million people. He is a recipient of several honors and awards, including the Shanti Swarup Bhatnagar Prize, B.M. Birla's Science Prize, National Award for Nanoscience and Nanotechnology, Indian Nanoscience and Nanotech Innovation Award, J.C. Bose National Fellowship, and the National Water Award. He is the winner of the Third World Academy, the World Academy of Sciences Prize in Chemistry for the year 2018. The nation conferred Padam Shri on him in 2020. He is also the recipient of Nikkei Asia Prize in 2020 and is the fellow of all the Science and Engineering Academies of India, as well as the Royal Society of Chemistry, the World Academy of Sciences, and the American Association for Advancement of Science. He also serves as distinguished professor in a few institutions in India and is also the graduate faculty of Purdue University. He has authored several books in the area of nanoscience and is also on the editorial boards of very prestigious journals such as the ACS Nano Chemistry of Materials, Analytical Chemistry, and so forth. He has been a recipient of the Lifetime Achievement Research Award of IIT Madras. And not only that, I think as part of his philanthropic activities, he supports a school in his village where there are about 500 students on the roll. I think we always say there is water everywhere, but not a drop to drink. I think Professor Pradeep will tell us more about it, and I shall introduce Professor Tiwari after the lecture of Professor Pradeep. He'll be talking to us on clean water using nanotechnology, the current status. Over to you, Pradeep.
Thank you, Alok. Let me share this screen.
Sir, before sharing, Pradeep sir, Seth sir wants to say something, sir.
No,
Yeah,
later,
please go ahead.
after both the talks.
Okay, sir. Thank you.
Okay. All right. Are you able to see the screen?
Yeah, we're able to see the screen.
Okay.
You just need to go full screen and that should be fine then.
I wonder what is happening. Hold on. Okay.
Yes, perfect. Yes, thank you.
Thank you. It is indeed a great pleasure to come and or in this online platform, not really coming, and speak about water and nanotechnology. First of all, let me thank President Ajoy Patak for directing the Academy Professor Manju Sharma for the insightful words, and Professor Prahlad Seth and Alok for coordinating this activity. Alok especially calling me, well, with forceful words to participate in this. It's always a pleasure. And Santosh, let me thank you also. On this day, let me also remember Professor K.J. Nath and his great contributions of VP Sharma and colleagues on this. Am I audible, Alok?
Yeah, you are audible.
Yeah, you're audible.
So on this day, I thought of starting out with a picture. So this is a picture that you have seen many, many times. This is the Earthrise that was pictured on December 24th, 1968 by the Apollo astronaut, William Antis. So this obviously talks about the only world that we have. That only world, as you see from this picture, is mostly water. And it is the right point to start this lecture. And we celebrate water today. We celebrate the environment today. That is essentially the unique Earth today. I thought when Professor Seth asked me the title, I thought I would give a brief glimpse into the science of how clean water using nanotech has been practiced today, not only by me, by a few other people. But then I realized that time is too short. So when I started putting things together, I realized that I will essentially be focusing on my work and not much of time is available for everything else. Water in a very a few words, if I were to speak about, many people have written books on this theme. The first sentence, our economic, social, and cultural outcomes can all be traced to water. And this is increasingly evident today. And water is the simplest and simultaneously the most complex problem. When I started looking at clean water using nanotech about 21 years ago, I was thinking that why is that these problems are not solved sufficiently fast enough? And from that time to putting a product in the field, it took over 12 years from the laboratory. And obviously, the journey has been extremely difficult. Then I realized how important it is to address many other challenges. So water appears very simple, but water is very complex. Everything, of course, every problem, whether it is health or hygiene or clothing or food or anything else, simplifies to water. So in the Sustainable Development Goals of the 17, almost 14 or 15 of them can be connected to water in one way or the other. I have been saying that affordable clean water is a problem of advanced materials. In several places, we have clean water. In several other places, we don't have water because the chemistry does not allow it. And so the solution for water, or if at all water is dirty, the solution is also in the form of advanced materials. The problem is advanced material solutions too. They are advanced materials. So there have been a number of adsorbents, several sensors, several catalysts, new phenomena, several new kinds of devices have appeared. And we have written extensively about these in many ways in publications and books and all that. But what key point today, when we look at in 2021, we realize that nanomaterials have become atomically precise. It is no more a large particle which can be characterized in terms of its diameter size. They have become atomically precise. So you can get a mass spectrum of a nanoparticle. And it is so precise that you have particles of this kind with well-defined mass spectrum, which means that you can crystallize them, you can have spectroscopy of them. You have a large number of aspects. So that means the chemistry that is relevant to water can also be understood with molecular details on such advanced materials. So we have studied quite a lot of such materials. And to give you a glimpse into how this is really helping the field, so here is a picture. So this picture was taken in Nadia district in West Bengal sometime in 2014 or so. So this boy is drawing water with this well, a cast iron pump, drawing water from a depth of 60 to 80 feet. And this pump itself is about 40 years old. And if you look at this cement platform, the platform is red in color because of iron oxide. So in this region, if there is this iron oxide stain, it is likely that it also contains arsenic. So if this pump has or puts out 160 parts per billion of arsenic in this region. So what did advanced science do? Well, we made a simple contraption, of course, over several years of work in this format, wherein 7 kilograms of arsenic removal medium is put in. And next point is very important. Without any additional pressure drop or any delay, this boy is pumping out water. One stroke of it, this pump produces 300 ml of water, and that is clean water conforming to US EPA norms. And you can get 1,000 liters of water from this pump a day, and you can run this for 4,000 liters not 4,000, 400,000 liters per year. And this can run for 2 years with that concentration before changing the material medium that is in there. So this is a smaller kind of a device. Obviously, it can go to much, much larger dimensions. I will show you in the course of this lecture. Now, the science is such that these materials, after taking up arsenic, the material can go back to the same soil. So it doesn't release any arsenic because it qualifies all the toxicity leaching protocols. And therefore, there is no need to take the arsenic-laden waste elsewhere to a processing plant and contaminate that. It goes back to the same soil with no additional arsenic release. So the science then, well, that was the kind of material. So the basis of these materials is a sand-like composite, which is built with biopolymers and containing nanoscale materials in them. And essentially it gives you a filtering medium. So you contaminated water passes through, and depending upon the kind of nanomaterial that you produce here or you put here, the kind of porosity and the properties that you engineer, you can remove contaminants of your choice. But obviously a nanomaterial, you would ask questions, or anybody would ask questions, do you have nanomaterials getting into water? No, so therefore nanotoxicity characteristics and evaluation become very important. What Alok is doing is very important. So if you take a nanoparticle deliberately and put it into an organism, you can see these nanoparticles getting into this organism, and you can do spectroscopy of these particles. In this particular case, plasmonic spectroscopy. But you can do many different kinds of spectroscopy. And Professor Khatak was, is an expert in photonics and things of this kind. So you can also study such bacteria or organisms passing through your material. And these materials, although they get destroyed and all that, there is no nanoparticle in them. So this is a particle after lysis of a bacterium after lysis through the nanomaterial. There is no nanoparticle in it. So one can understand such science using advanced materials. Now, over the years, several new materials have come. And all of these materials have one characteristic that is called water positive. That is, let us say if you put 1 liter of water to produce this material, because all these synthesis is happening in water, we wanted to eliminate all organics in this process. So everything is happening in water at room temperature. Although with soluble ingredients, you produce these materials at room temperature, what you get out is insoluble sand-like composites. So these are like creating calcium carbonate or any kind of organism, seashells, with soluble ingredients. And they are very porous. And therefore, they are green. But the question is that, let us say, if you put 1 liter of water for their production, how much of water can it really produce? So our materials can produce more than 500 to 1,000 liters. So you have 2 orders of magnitude or 3 orders of magnitude water produced, and therefore these are water positive materials. All of them are water positive. So in the case of arsenic, what we have done is created a very well-known, extremely common material, iron oxyhydroxide. But we stabilized a metastable form of iron oxyhydroxide that has very large capacity for arsenic 3+ and 5+ uptake. And in detail, they are about 2 nanometer or so size structures. If you leave them in regular atmosphere conditions, they lose all their adsorption characteristics of the kind that I mentioned. But because of this confinement that we introduce, we can keep these materials in this form, and we characterize them with several tools. And what happens is that you have this arsenite or arsenate species, and they sit on specific adsorption sites of these particles. And we understand how this adsorption occurs using spectroscopy, and we model these. So if we given nanoparticle, we understand how many different kinds of sites are possible. And we see that a very large adsorption capacity is there. So how does it, what does it mean in the field? So you create a filter, let us say 25 grams or 20 to 25 grams of this material is present here, and you pass arsenic containing water about 200 parts per billion, both arsenic 3+ and 5+ combined, 100 + 100, pass it through, and you see 1,200 liters of arsenic containing water has been cleaned with this material. And that is contaminated water. Not arsenic is not colored, but we deliberately color it with iron, and we find, so this is the clean water that you get. Now, this is what I showed you at the beginning of that picture. So what does it mean? The large adsorption capacity that you have would mean that a regular plant of this kind supplying water to a community, again in West Bengal, Nadia district again, it is spread over a 40 cents of land area, supplying water to 2,500 people. Now, this can come down to less than 3 cents of land area, and in extremely populous region such as West Bengal, this becomes a great advantage. So in addition, there are several other factors of price, etc. we will come to. So that's the input concentration that you have, and that is the output concentration you have. This unit has been functional for more than 7 years now. So it sort of simplifies logistics in the field. Now, they have been installed in several places. Some of them are arsenic, some of them are fluoride, some of them are regular water supply schemes. Now, there are many, many such smaller units, as I just mentioned. This is now how a regular unit would look like. Typically, it supplies water to about 1,000 to 2,500 people in a small village kind of a setting. So what you are seeing is a 100 kiloliter capacity unit. So what does it mean for people? It means affordable. We started out saying that nanotechnology for affordable water, our definition was less than 5 paisa per liter. But today you look at this costing. You look at all costing combined, it is 2.1 paisa per liter. So this incidentally, it puts all costing together, all capital costing, consumables costing, the maintenance of the units, etc. So where is it going? The way it is going, as we had written in this article last year, was that along with such solutions, we have to have monitoring mechanisms, not only water quality, but also water quantity. And I will show you examples of that. So today, such installations are done in the field, and they are monitored real time. And I'm showing you a movie that we prepared a few months ago in some installations in Punjab. I don't know to what extent this will be transmitting really well in this online platform, but let me play this video. Just 2 minutes. So what I told you is that affordable clean water with geotagged locations, one can install today, and that is being done. This is an effort of 102 such installations. 52 of those installations are with IoT today, and more are getting installed. So affordable clean water, free of contaminants, is not a distant dream anymore. All it needs is people to come together. But this is about material story, but there are many other efforts. For example, atmospheric water harvesting. We create nanostructures like these, and using these nanostructures, it is possible to produce water. This is by active cooling. So you create such nanostructures similar to grass, cool these surfaces, and when you cool these surfaces, you condense humidity on them. And today, there is this startup company called Vayu Gel. It is producing 100, 400, 1,000, and 2,000 liters of clean water every day. But the way that world is going is that advanced nanomaterials are used to create water just with sunlight. So you create nanostructures like these, porous structures, which have specific sites for water uptake. They uptake water in the night, and they contain this water. And in the morning, in the daytime, when they absorb sunlight, the absorbed water is released, and that water is condensed, and you get water during daytime. So this is something that is very much possible, and many people have demonstrated this, although today such materials have not come to the marketplace yet. There are several 2D materials. We create holes in such materials, nanoscale holes in them, and these are nanoscale holes. But such nanoscale holes in this molybdenum sulfide, these are molybdenum-rich holes, just about 4 or 5 nanometers. And when you have such holes and you pass water and sunlight, and it produces hydrogen peroxide, and that destroys organisms, and it also destroys viruses. And you can create such structures, and from bacterial loads of this kind, bacterial loads come down if you pass water through. So today, a large number of technologies have come in very many categories, and several products are there. I showed you products of this kind. I did not show you products of this kind called capacitive deionization, especially in the brackish water areas, as well as areas where there is seawater intrusion. Several new developments are there with electrochemistry. We also have a startup company in this area. Atmospheric water harvesting is what I just showed you just a few minutes ago. Across the world, nanotechnology has advanced tremendously. So these are graphenic membranes. There is this person in Manchester, along with Ande Game and several people across, creating functional nanostructures wherein porosity can be controlled by electricity. And water can pass through such structures, and under appropriate condition, water flow can be stopped as well. And this kind of structures have today attracted a lot of attention. They are getting inserted into regular membranes. In our own country, this is Professor Kanna Sureshan from IISER Thiruvananthapuram. He is creating several advanced organic materials. They can uptake water and also oil in selective conditions. This is a video. For want of time and bandwidth, I'm not playing this. And such materials can also harvest droplets. And water harvesting, fog harvesting has been demonstrated by such materials. Another very advanced new direction in this area is clathrate hydrates. As you know, clathrate hydrates are plenty, and these are methane trapped in ice. And quite a lot of that is existing under the ocean bed. But clathrate hydrate is one wherein there is only methane and pure water. So when methane is taken out of these for energy purposes, what is left behind is pure water. And we have been working in this area for quite some time. And what happens is that there is this new technology called hydrate-based desalination. So you extract hydrate from sea, or in whatever situations that you have, remove the gas for your energy purposes. What is left behind is water. You get both energy and water in one stroke. So this kind of science is happening extensively, especially in NUS, and some amount of that work is happening in India too. But this kind of science will not be complete without advanced sensors. So this is from the group of Whitesides. Although this kind of science is already 3 years old, today, my friends have developed spectroscopies on a mobile phone. And using such mobile phone-based spectroscopy, they are in a position to monitor water real time. And hopefully in about 2 years or 3 years time, the mobile phones will contain advanced nano spectrophotometers with which water quality can be analyzed. So where is this going to? This is going to a hydroinformatics kind of a platform wherein water sensors, data are put into a virtual reality and an analytics platform with entire water data of the country put together. So we are putting a hydroinformatics dashboard for the government of Punjab. So with this kind of data, this is under discussion today. It has not really come up, but this is the state of Punjab. But let me show you one small data here. So where is this going to? This ultimately, if all this data is available, the physical infrastructure of water infrastructure can have a digital analog, what would be called a digital twin of water resources. That digital twin will take our country to greater heights. So in Punjab, 12,500 or so wells are monitored continuously. This is what is so alarming. What is alarming is that the arsenic is expanding in this region, this time window. Arsenic is expanding, and this is the highest arsenic, smallest arsenic, and this is safe water. And there are several pockets coming. And to take such science forward, in order to find solutions, we need to have a larger organization where anybody can come with an idea in water, build a technology and take it with them. And that is called the International Center for Clean Water. We have built one such center at IIT Madras with philanthropic support. And this is the IIT Madras Research Park in the larger ecosystem. What I showed you is part of that. And this science was done by my research group. And over the years, several people have contributed. This is the Amrit team. Anion and metal removal by Indian technology is called Amrit. And this team, all of them are our IIT Madras students. Several of them own companies today, and many have obtained PhD. And this is my team of previous people who have built water technologies and several startup companies and governments. I have been fortunate in obtaining funds from the Department of Science and Technology over the years. So this entire research is because of DST Madras, and my institute has been solidly behind. Let me thank Professor Bhaskar Ramamurthy, who allowed me to convert a wet chemistry laboratory to a pilot plant of production. Thank you all, and I will be glad to take questions if you have. Alok, thank you very much.
Thanks very much indeed, Pradeep. Excellent exposition of absolute fundamental science, all the way up to how you develop that science into technology for the benefit of masses, and how wonderfully it has been deployed in various states. Professor Seth, how do you plan? Do you want to have some questions, or should we move to the next speaker, sir?
I think if there are any questions we can take up, there is an interactive session also.
All right.
So after the second talk, we can take up.
So Pradeep, thank you very much. We'll take up the questions later on. And I would now like to introduce our next speaker, a distinguished speaker, Dr. V.M. Tiwari, a dear friend and a director of CSIR NGRI Hyderabad. Dr. Tiwari's research interests primarily focus on deciphering subsurface mass distribution and mass transport relevant to a wide range of scientific and societal applications, such as elucidating structure and dynamics of different geological settings in Indian lithosphere, variation in water storage over Indian subcontinent, and mapping of sub-ballistic sediments. I think he has been not only very well cited in terms of his research articles, but also he has been recipient of several honors and awards, both from INSA and from CSIR, also by the UP Council of Science and Technology. He is also fellow of NASI and a member of several national and international committees. But as a head of an institution, I think he has steered several very important mission programs of the Government of India, which have led to technology development and in identifying subsurface waters using airborne technologies. So I request Professor Tiwari to go ahead and give his talk on groundwater management under changing climate. Dr. Tiwari, please. So I think you'll need to change the setting to duplicate the. Yeah, that's good enough. So if you just make Full screen.
Professor Dhawal, is it fine?
Yeah, just go to the top and it says display settings. Yeah, drop down and say duplicate slide. Yeah, that's perfect. Thank you. Go ahead.
Okay. So let me first thank NASI and particularly Professor Seth. And it's very inspiring that we have the colleagues and mentors like Professor Seth, who is in this stage also so much bothered to see that science is not done at the best way, but also made science known to the people and deployed in the field. We also always had a privilege of having respected Professor Manju Sharma ji, and I have particularly great regard not only because she has been associated with NASI, but she also is one of the pillars in the sciences and connected with the generation with education. Professor Ghatak, the president of the NASI, and Professor Chandrima Shah, President ISA. Namaskar, all fellow of the academies and other distinguished colleagues today joined through online platform. We had a wonderful disposition about how the nanotechnology or the chemical sciences can directly contribute towards the science which appears to be related with the physical sciences. And I always say that water is the only subject which brings chemists, biologists, and physicists together and engineers to get them implemented in the field. And so water, as we thought, is the integrator in our ancient time remains to be integrator even in the modern science as well. Am I? Yeah. So what I am going to do in coming 20 minutes, that why do we need so much attention on water? Already majority of the issues mentioned, but for the sake of connectivity with how the solutions are required, I would have the brief introduction about the requirement of the water and in changing climate, how water availability will change. Where do we have water in India and how much? And with the present condition of the water depletion and contamination, how with few examples can we provide solutions which can remain sustainable over the years. Let me go back to this slide which shows left-hand side, what we see today is the science of our modern day understanding, and right side, what we see today is what had been thought of by our ancestors thousands of years back. So the understanding of how water comes, how they remain and sustain the life over the earth is quite well known over the thousands of years through hydrological cycle, which brings water from the ocean to the atmosphere, and through rain it goes inside the earth as well as on the surface of earth and again goes to ocean. It's such a simple way of looking to the entire water cycle, which today's world sustain our ecosystem and environment. But when we start quantifying each components at the spatial location, so temporal variability uh, as well as the spatial distribution makes the things much more complex. And here comes how the science and technological development can address the issue. We all know that climate is changing. There is no more discussion, though there are people still think that there are possibility of the climate making impact. But with the different climatic models available today, we can see that how the water resources will change over the different parts of the world in terms of their changes. And we can also say that how particularly what is the groundwater response to the climate change. And interestingly, if you see from these global models over the Indian region, we are going to get impacted in much shorter time than many other parts of the world where the climate change will impact over the hundreds of years. And therefore, being the country, agrarian country, there is a need of very much science-based solution development to see that the climatic and anthropogenic impacts are taken care of. And if we see that one of the things which is very much dependent on the surface and subsurface condition is recharge. And if we try to quantify the runoff and the population rate, it will change based on the change in the climatic condition, and therefore the availability of the groundwater as well as the surface water in different parts of the world, and especially in India. So one of the impact which we often see is that because of the climatic change, the change in the sea level is likely to impact very heavily in the coastal region, and India having a large coastal region might have impact on the groundwater like saltwater intrusions and the subsidence. And therefore, if we see the entire world and the crisis which is going to be there in the future, and in fact it is already we see they are going to impact the countries like India very much. And if we see at the larger dimension, the African, Asian countries are very much impacted, and particularly the two regions connecting India, Pakistan, and Bangladesh are, will be on the top. So what do we need? So there is a we see that there is a global change in the groundwater situation. There is a change in the groundwater demand, and therefore we need to have a strong management through which we can see that how much influx is going to be utilized in future so that the sustainability is maintained. So let us see what do we have and where do we spend water. And if you see, particularly the countries like India, we spend 91% of water towards agriculture sector. And if you see present day, the major part of that, still 75% comes from the groundwater. And another very important thing which I would like to emphasize here, that we are talking of the water quality. We need to see in a very large perspective of the use of only 5 to 7%, which is going to be for domestic purposes or for the drinking purposes. So still 91% of water which are going to be used for agriculture through agricultural products, they still remain through food chain and coming to the human and animal bodies. So we need to have a much more bigger plan than only thinking of removal of the contaminant for the potable purposes. And I would like to show that how some of the contaminants, which Professor Pradeep has very nicely shown that how they are removed like arsenic, they are increasing very fast and can be managed through the management of the groundwater in the area because they are particularly geogenic, which are the nature-based. We also see a large part of the area of the country, the groundwater declining very fast. And Punjab, the place where Professor Pradeep has shown few examples, is on the top. And second most, where we are virtually sitting, is the state of Uttar Pradesh. And therefore, these two most populated and agrarian areas require much more better management of the water, though we have the Ganga brought through the all sources coming down up to the West Bengal and Bangladesh and going to the sea. So what happens because of these agriculture conditions? We see that the large part of the Indo-Gangetic plain, right from the Indus Basin, going up to the Ganga Basin, downwards to the Bangladesh, because of the large agriculture, draws huge amount of the groundwater, leading to the largest depletion of the groundwater in world. And there are many other environmental impact, and one of that can be traced, like possibly connecting with the lithosphere, where we are seeing a large number of area getting subsiding and may lead to a small or micro earthquakes. So these water requirements, how can they be managed? If we see particularly over the country, probably many of the experts joining this virtual meeting must be knowing it, but it's, I thought that it would be good to have an overview, making the point clear to the Science Academy, having the president of the two Science Academy over here to take the message forward. In fact, 2 years back, I still remember the book which we got released by INSA, Professor Chandrima Saha, then Vice President of INSA was also there. So many of the things I draw from that book, What a Future of India, and here we can see that large number of area not only getting contaminated, probably and mostly I find geogenic, also fluoride solutions. So one of the biggest challenge what we see, which is going to impact the economy as well as the food resources, is the availability of the water for the agriculture sector. And by 2050, if we see our demand is going to be very high, and if we don't meet 6% of GDP might be lost only because of the climatic impact and anthropogenic water utilization towards the agriculture. These were again some pictures showing that what are the areas where the saline waters are likely to be invaded and required solution. And if we summarize all these together, what we find in the larger context of the groundwater, there could be 4 subdivisions where there are contaminations, where are large depletions because of the large withdrawal for the different purposes, and all this becomes much more complex when we have the change of the climate in the very complex hydrogeological regions. And to have adequate replenishable groundwater, we need to go from the bottom of this pyramid first to know the complex hydrogeology, climate change, how it is going to change in future, and then manage the contaminant as well as the water depletion. So here is one example how our subsurface life hydrogeology, 2/3 of our country is covered with the hard rock terrain, and it is appearing to be so complex. And therefore, we need to have a very good map of the few meters near surface. So why do we need that? Because of the complexity, when we are going to have the water budget, it will be so difficult. So I take one example here quickly of the Ganga River basin, that if first we can do it at quantification at the basin level, and there the remote sensing data as well as the ground-based observations can be tied together to have a model. And here we have made a simulation to a numerical model, and we could able to demonstrate that the present day estimates what had been done with the empirical relations are as of as 100%. So if we see the estimates, they show around 23 to 30% of vote transpiration. Here we find it is more than 45 to 60% comparing, and that reduces the water availability in the Ganga River basin. With this very fine level example of the management of the groundwater, I would like to emphasize this is the bottom top. What you see is the map prepared using the geophysical technology, a very precise aquifer maps, which delineates the aquifer zone where the water resides. And what we find that there are 2 aquifer systems in Ganga River basin, and this is the place from the Patna in Bihar, and it is separated by another layer, which is very thin layer of the clay. And when this thin layer becomes much thin, the hydraulic resistance of water, and one of the aquifer system is arsenic contaminated and another is not. So because of the disturbance in the hydraulic condition, the arsenic contaminated water joins the fresh water. And this can be managed if we know that how much recharge takes place for the first aquifer, which is generally used for the most potable purposes, as well as majority of the ground water used to the agriculture. We will also be able to manage and reduce the contaminant in the groundwater. So here also we use all these and set up a numerical three-dimensional model where we can make these decisions. And what we could be able to see that there are three conditions which we have put together, where the business as usual and business when the drawn is more than the from the first aquifer system and second aquifer system, and we could show that if we properly plan, there could be possibility of uncontaminated sustained groundwater availability in the region even can be shown at the village level. And this is the chart here. Okay. So the second example here I would like to show, which we have recently done for the smart city Surat. And here is a three-dimensional map of the system, and blue color shows the water, which has mainly the line, and we can see that over the period of time, this water moves, and even this water moves in the summer towards the land side, and again in the time when the aquifer gets recharged, again the water goes and hydraulic condition push it towards the sea. And this interface can very well be mapped and can be monitored. So what needs to be done? Make a measurement, monitor it, and also make the projection, or we can say prediction. So it's a kind of the 3M measure, monitor, and model. And now technologies are available and very well within in our capability limit in the India that we can do. This is one of the finest example which our institute has done recently, and we have delivered, which led to the even award to the Surat Municipal Corporation for this. I would two examples I talked of, which are more towards the climate driven, and another was anthropogenic, but again it was geogenic contamination, arsenic. The third one I take it from the a watershed near the Hyderabad, where the perennial contaminant groundwater seepage in the city where the large pharma companies are located. And what we try to do through our innovative approach to first map the aquifer and monitor with satellite-based information the surface temperature anomalies, as well as the okay, I think mics are still on. So, and these anomalies are verified using the time-bound electrical resistivity tomography, and afterwards we could set up a model again, which would make a projection for the dump of the contaminants by the all pharma companies, and this leads to the situation that now the contaminant water is now made less contaminant. I don't say that free of contaminant, but much better than what it was, and it is in the terms of economy, is more than almost few hundred crores every year for the pharmaceutical companies to operate sustainably. Another example here I would again like to give in Hyderabad, where we try to see that how rapid urbanization without the planning, taking into account of the groundwater system and surface water system, leads to large depletion of the groundwater. and they can be very well managed if they are planned. And what we find that almost like few percent, almost 10% of the decline of the groundwater because of the very fast urbanization in not a planned way. And similarly, when the surface waters also get contaminated, I would not go uh, much more details. I can answer some questions when coming back. I am just trying to find out and let you know that there are problems, and the problems also have the scientific solutions. And in a period of time, these tools can allow to have like decision support tool which can be given any a villager, a panchayat, where they can say that what kind of the if they have the without any plan, management plan, and if they change the different crops, what kind of the requirement will be there. And if they change management plan as well as the crops, they can have the sustainable water. And certainly, every decision maker would like to have such decision support tool for managing the groundwater. And therefore, such scientific interventions would be very helpful for the large areas. I would like to give a success story which we had recently made in 2 years' time and being replicated at many parts of the Telangana, where we could show that even making 2 or 3 percolation tanks can change the scenario of agriculture and so the economy. And you can say that just in few years, we can regenerate around 18% of the agricultural land for the paddy crops. And it was only possible once we know about it. So what do we need? We need a clear-cut paradigm shift, and I'm sure that the academic role will make a very important impact through the decision making, showing that how science, management, policy, and education, which Dr. Sharma ji had started reaching to the people through organizing the gel meeting, and we bring the hydrological model together for the decision makers and the public to ensure the appropriate information in decision making. But even at the smaller level, we can do, each individual can do, and we can tell it. And I would like to end with these talks with this, that each food, what we eat every day, what we take, has their footprints, and they are very well seen, that right from samosa to the biryani, what kinds of the footprints they have from the water. And because of this, you all must have seen this, but again, I thought to bring to your notice that based on the IPCC report, which was published some time back, and also the gist of that brought in the Nature, 12th August 2019, that even our small change in the food habit can have impact on climate through the water cycle. So what do we want to have? We can choose, and we can make people to choose either the left side or the right side of the slide. And with this, I once again thank the Professor Seth, the NASI, Professor Seth organizer, and our very dear colleague, Professor Dhawan, for getting this opportunity for me to let all of you get reminded that the problem we have, but also we have the solution for the problem. Thank you very much.
Thank you very much, Dr. Tiwari. Excellent exposition again of technology and how it has been used and utilized for benefit of the masses. I think this is again an exposition of how NGRI has been working relentlessly under your dynamic leadership to ensure that we get the best of technology out there for various state governments. So I request Professor Seth to make his remarks, and then we can go to Professor Khurana for her remarks.
Well, I don't have much remark to say, but to thank both the speakers for excellent presentation. And it was really eye-opening that how nanotechnology has been used to make the various filters and which can utilize in the mass scale utilization taking place. And I see a lot of comments which have come in the chat box appreciating the technologies and appreciating the presentations. That's from Dr. Kamboj, I saw, Dr. Tripathi, Dr. Dhiman, and many others spending. And how important are the modeling? It's again very important that what Dr. Tiwari just mentioned about that in as the water crisis is going and is coming, and I think this hydrological modeling is so important that whatever water is there is sourcing and then getting it and charging our aquifers and particularly groundwater management. So these both talks were so important, and they have provided us a lot of new information. I must thank Dr. Alok Dhawan because, as he mentioned, because the time was so short. So, and his name was there. NASI very rightly put him there to coordinate. And then I just called him, and that and he said, we decided, and I'm sure our decision has been very useful for the audience for getting these two very, very important and very, very busy speakers, so who could come and lend their time and share what excellent work they are doing. And with this, I think I don't see any questions in the chat box, but if anybody has a question or something, they can do it. And then otherwise we'll move and have remarks by Dr. Khurana. Any question or any remark from anybody?
Professor Seth, this is Pradeep. Although I don't have, there is no question for me. Let me ask a question to Dr. Tiwari. It's rather I wanted a clarification. You know, with so many floods that are happening and several regions of the country receiving excessive rainfall in certain times in the recent past, Kerala, Chennai, several other places. I was wondering, with the right kind of water management practices, in this, with our scientific intervention, can floods be completely eliminated, even with the kind of waterfalls that we are having? The rainfall that we are having. What is our scientific input today?
Okay, you are very much aware about the recent programs which Ministry of Sciences has launched on the, particularly on the urban floods. But let me also tell you that there are different kinds of the hydrogeological setups, and they have percolation capacity. So if we have the water in a very short duration of time, the intensity of the rainfall is going to make a lot of difference. Therefore, the runoff becomes much high, and they lead to flood. And the present kind of the presently one thing which I have shown to you, particularly how the urbanization is changing the groundwater regime. It also changes the runoff regime. And the unplanned, we have the planning, but we do not have planning of the surface runoff. And that also needs to be taken care when we plan smart cities. And such kind of problems can be certainly minimized if not eliminated. There are another kind of the issues which we see like the often flood in Bihar. You must have heard 2008 Kosi flood, which had brought almost 4,000 cubic kilometer of water spread large part of the area. So they have the different kind of the dimensions and also the possibility of management. The another aspect what you mentioned that we had started working with the Ministry of Jal Shakti, and last year we had signed one MOU for mapping of arid region of northwest India. And the whole purpose of that is that if we have the excess amount of water in upper reaches, like in the part of the Himachal and Punjab and Kashmir, can we divert through the subsurface value channel if identified and connectivity established through them, bringing even the third desert uh, having a possibility of water. So, of course, there are different dimensions required to tackle the kinds of problems we are facing, and they all have the possibility of the solutions. And I'm sure that with present day, the uh, excitement in the public and the decision-making bodies uh, will be able to address few of them in future.
Thank you.
Okay. Dr. Pradeep, I have a question. These bigger plants which you have installed at Amritsar and other places, what is the requirement for the people of the upkeeping of those plants? Do they the sieves, etc., have to get clogged, or do you have to recharge them after a certain time, or they can go on for some time limits?
In case of, thank you for this question. In case of maintenance for the real user or the plant operator, this works like any ordinary plant that they have been used to. And so they have all been used to other materials like activated carbon or alumina. So similar kind of operating practices. They don't change at all. The only thing is that because many of these regions also contain significant amount of iron in water, there is a substantial back flushing that is required, or backwash that is required for the safe and continuous maintenance of these units. And these are these days with automatic triggers, this can be done. And operators are trained in this. The IoT system that I just mentioned allows also SMS and such other alerts to be done. And in terms of changing the filter, medium, etc., it depends upon the concentration in the water, typically about once in 2 years or 2.5 years.
Okay, thank you. Thank you. Dr. Shah, you want to make any comment?
Yes, this is a very, very informative and very interesting session that we had. And really, to tell you the truth, I didn't have so much exposure on what is being done on water purification in India. This is really a learning experience. And I also would like to acknowledge NASI for arranging this and all their timely conferences and webinars they are having. This is one of the most interesting ones that I have attended. I have a question, which is sort of a question of ignorance, and this is addressed to household users of water. Because I read somewhere that the Green Tribunal has discouraged the use of RO water purification in houses. Do you have any knowledge on this, on why they have done this?
Well, RO today, the way RO is practiced, you oftentimes put the total dissolved solids at 30 ppm to 60 ppm or so for better taste of water. Although what is needed is in the range of 130 ppm to about 200, 300 ppm. Although many people don't like the 200, 300, they are okay with 130. Now, but then people are so used to this kind of mineral-less water, and because of its extreme, maybe a better feel that they have. And so we did conduct studies in IIT Madras, for example, and you give them quality water at 130 ppm, 200 ppm, students refuse to drink it because they see that this is different from my water that I have been used to. So our purification companies in general put it at 30 to 60 ppm, and that is a big health hazard, and there have been several scientific studies in this regard with regard to calcium deficiency, etc. So the government has taken a position on this, that we should have healthy water of that kind. That is one aspect. The other aspect is with regard to water wastage, which is something else. Of course, that also has to be considered. Yeah.
Professor Pradeep, there is another issue which probably you can rightly take it and answer it, of the sludge. So how are we, suppose if we had to take the example of arsenic, and if we had to convert the all groundwater potability for the drinking purposes, the amount of this which we'll produce, how will we put them and how will sustain them environmentally? That's another issue which I think we need to bring, and if there is a nanotechnological solution for that, that might be also used.
Absolutely, a very important point. But in the context of village water purification units, the water that is extracted from the region is distributed in the region. The sludge that is produced, if it can be locally contained in the same soil or same region with no additional release of arsenic, that would be the right approach that we have. That is good, and this is what we have been practicing. However, in the context of, let us say, a large water distribution network, wherein water is sourced from several places and distributed in a metropolis, in such situations, what would you do? The sludge that is produced has to be disposed of elsewhere. So this is where quality of the materials and its toxicity leaching characteristics have to be investigated. The current materials that we have talked about, they are all disposable without additional increase in arsenic concentration in a reasonable time window. In the soil conditions that are prevailing in the region. So we conduct these studies, but then if the sludge, the right kind of materials are not there, how the sludge should be managed is an important question that has to be assessed, and this is a part of the tender criterion today in implementing arsenic purification plants.
Thank you.
Can I ask one more question?
Yeah, please go ahead.
This is about the in areas where I stay and in some other places I've seen the turbidity of water is very high. So in such conditions where turbidity is so high, these plants have an extra item to remove the turbidity, or that it goes directly as a turbid water?
Absolutely an important point. Turbidity in these regions, yes, of course it is there. That is mostly to do with ion turbidity, colloidal ion turbidity. And this has to be removed as a pre-filter. And this is where most of the previous technologies have failed, because there is no way that sludge of iron at a very, very high concentration, something like several hundred times higher than the arsenic concentration. How can that be addressed sustainably for such large volumes of water? That has been an issue. And this is where several new materials have come and removes turbidity in advance before arsenic is filtered.
Oh, you are muted, look like, yeah.
Can I have some comments? No? With the urbanization of the metropolitan cities, like I'm in Gurgaon, I find I moved from Gujarat to Gurgaon, found a lot of consumption of water, and we are facing a lot of problems as far as having good water. So can we kind of start some kind of educative system where we can tell the builders and the colonials that they can use the Japanese, the Tokyo system, where the wastewater by the hand washing, etc., is used for the other purposes, so that the consumption of water is reduced. Otherwise, what's happening? That a lot of the fresh water is being used for other applications. So some kind of education system or some kind of this program, if can be launched, that may be very useful. I just think so.
In the long run, with the rapid urbanization, without grey water recycling at the source level, some kind of a micro treatment of grey water, urbanization cannot proceed the way it is. And several new technologies have come. These technologies are also debating in the marketplace today. It is today possible to think about, let us say, 50, 60 apartment complexes to have affordable grey water recycling. The cost that water recovered is almost equal to the water bill that they save. So it is indeed possible to conduct recycling that way.
So, Dr. Kamboja has some point to make.
Yes, I want to ask one question to the experts. We have floods every year caused by Brahmaputra of the Northeast, which not only affects the total Northeast, but also Bihar and other regions. Can we harvest this water and take it to the south, north-south linkage? Even we have floods in the north also. The good water is allowed to go back to sea, and we are searching for water only from the aquifers of the earth. Dr. Pradeep or Dr.
Tiwari.
Dr. Tiwari to answer. This is his domain. Yeah.
There are a couple of things which we have to keep in mind. If we see the topographical variation, for example, if you see south of 22 degree are the Narmada River, south of Narmada River. Almost we are going 200 meters above than the level what we have in the Ganga or Brahmaputra. So what does it mean? It means that you have to design the way that the potential, natural potential would not allow water to flow. And therefore, we need to have the artificial way of putting canal or the other way. Now you think there are also the issues being talked that water energy nexus. So in order of getting that much of water, are we going to spend that much of energy and how economical it is? But certainly at the regional scale level, like suppose if I say that I can connect Krishna and Godavari at certain places to a canal and excess water at some places can be diverted. Same thing if we can do in the north where some flood water can be diverted. But bringing Brahmaputra to south appeared to be not so good idea. Secondly, that we are also going to change the environmental conditions while transporting this water. So there are plans of interlinking of water. Government has already started, and to certain extent, it is planned to be done, but not that kind of projection as you have suggested. But it's a part of the surface water management, and if we can do it, for example, I will tell you, you have raised very one important thing. Take the example of Telangana, where we stay in Hyderabad. In 1980, the total agriculture, if we see in the entire Telangana, the 70% of the agriculture was fed by the surface water. And 2020, the present state is 70% agriculture is fed by the groundwater. So management of the surface water is very important, and the excess water from the surplus areas can be useful. So you must be knowing, sir, already there are plans of the government of India, and they have already started one interlinking in the water in the south.
Thank you. Back to Alok. Dr. Dhawan, you're there?
Sir, I think as per program, now I'll request Professor Paramjit Khurana, General Secretary of NASI, to give her remarks, please.
Good evening, everyone. It's been a wonderful webinar with two excellent experts speaking on very diverse topics and a very informative webinar, I would say. Very briefly, I would only say that water, we all know, is the lifeline of all life on this planet. I view water from a different perspective. I feel water is one substance which has no substitute. Even for blood, you have artificial blood, but water is not replaceable by any other subject, any other substance. No amount of wealth can replace freshwater resources. And since India is an agricultural economy, and I, being a plant scientist, I'm very deeply attached to this notion that there can be no agriculture without freshwater resources. And that is why I think there is a compelling need to not only provide clean water for drinking and to bring in newer technologies to do that, but I think it is very important to manage our fresh water resources. That will remain the bigger challenge. We do talk of water quality and water purification, especially under the changing climatic conditions. And while the climatic conditions adversely affect agriculture, water is one of the major factors. Having said that, I'm glad that NASI is spearheading many of these efforts for the last few decades at the grassroots levels, whether it is the activation of the bodies or the establishment of the river galleries and holding talks for school children, college students, and others. And keeping in sync with the theme of the present world environment day, that is to restore, recreate, and reimagine, maybe not exactly in the same order, So fresh water availability, I think, should be given importance. And that is why I would like to congratulate the organizers today of getting such excellent experts. Dr. Pradeep from Chennai, who mentioned about the nanomaterials for water purification. A beautiful film also on the how drinking water can be created in Punjab. Atmospheric water harvesting. I've always studied about this, read about this, about efforts done in Japan and other countries, but it was very heartening to see that, yes, these efforts have started in our country also. I think it was partially because of my ignorance, but I was very happy. Another thing which attracted my attention was, besides disinfection, the disinfection part also. I think we need to have him again for another lecture on that aspect, disinfection and contamination problems. But the clathrate, I could not get enough of that. I wish we could have them speak more on the clathrates from the ocean beds and how they can be the future source of water. I think that was one potential field which I think is very. Dr. Tiwari's lecture, I started off very nicely to see how the groundwater was managed, but then I lost my internet connection and I missed a little bit of it, but it came in well in time, I would say. So I would not say much, but being a molecular biologist and especially a plant scientist, I would like to add that yes, plant scientists are also striving to tailor plants for growth under suboptimal water conditions, be it contamination of salt, be it contamination of heavy metals, or situations where water is limited, a drought-like condition. So we also try to study the mechanism of water uptake in plants naturally and see how the limiting conditions affect them and how the plants can circumvent to a certain extent. Dr. Tiwari did mention the water footprints and our agricultural distribution. I think the water footprints go in a long way in forecasting what crops need to be grown where, in which conditions. And when we fiddle with that, we face the consequences. So in the end, I would only want to again congratulate the organizers. And I think it was a very nice amalgamation of a technology, engineering, hydrology-driven aspect of giving us a different perspective as to water and how water will affect and how the management of water policy is important. And more importantly, I think we need to see that these policies are executed properly, irrespective of the geographical distributions. Thank you very much.
Thank you very much, Professor Khurana. May I now request Professor Satyadev for his concluding remarks and the vote of thanks, please.
Okay, am I audible to everybody?
Yes, sir. Yes, sir, you're audible, sir.
Okay. So first of all, I would like to congratulate Professor P.K.Seth, coordinator of today's webinar, that he has come out with an idea to celebrate the World Environment Day today under the auspices of NASI. In fact, when we did not have this COVID pandemic earlier, we used to have a lot of physical meetings on all these topics, particularly on water and other very good topics. We used to have seminars, conferences, workshops. I remember having attended several workshops conducted by Professor V.P. Sharma and K.J. Nath. Wonderful speakers came there and actually made their presentations very nice, and it was really enjoying the lectures given by all those people. I would also like to mention that this program was on the new initiative program of NASI, and the leader of that new initiative program is Dr. Manju Sharma, who is actually the leader of all these various programs, and they were in abundance earlier before this pandemic came. But during the pandemic time, even a lot of webinars are being organized under the new initiative program. I would like to thank and appreciate the presence of our President, NASI, Professor Ajay Ghatak. He, in fact, narrated the entire chronology of the work done by NASI on water, starting from V.P. Sharma. Even he mentioned that in the Bundelkhand area, there were Bahulis who were really rejuvenated by Professor V.P. Sharma by going on the site. Earlier, they were abandoned because the water was very very bad. It was unusable. But they took care and they made it usable and in fact refurnished it completely. And now people are using all that bobblies very enthusiastically. I would also like to thank Professor Ajay Alok Dhawan, who has been an expert on these topics, and he got these two experts, very good experts, and we all enjoyed the lectures given by the two experts, particularly by Professor T. Pradeep from IIT Chennai and Professor V.M. Tiwari from Hyderabad. In fact, these two lectures, I was listening, and I found that they were of the research level. In fact, they also discussed many things which are of practical use. For example, separating arsenic from the water. That was the main objective of the talk by Professor T. Pradeep. And even he has made some instruments which can be used profitably and at a very cheap rate, even economically. So ultimately, these are going to become public, and for common masses, they are really going to be wonderful things in the days to come. And Professor Tiwari also, he in fact gave a very good talk how to manage underground water through in the presence of climate change. These are all really difficult topics. In fact, for a layman, it's very difficult to understand how these atmospheric changes, they affect the groundwater, quality of the groundwater and so on. But these are all really crucial issues which have been tackled and very nicely explained by Dr. V.M. Tiwari. I also thank Professor Saha for being present here and making our webinar as a well-attended webinar. I, in fact, thank all the scientists who have been present in this webinar, which has been a wonderful thing. And we all enjoyed, even as a layman, we enjoyed, because the topics or the problems which they have solved really matter. They matter a lot to us. I was thinking, in fact, in the beginning, that during Vedic period, when they all, at least Indians, they understood the importance of the plants and trees and so on, all these environment. They understood this because Ayurveda came from all these areas. And at that time, there was no attack on the existence of these waters and plants, because the population was very small and the uses were also very small, but they were very useful. And this continued, even the rivers, they were all very pure. Not much of pollution was there in the rivers. People used to drink the waters of these various rivers. And this continued until the machine age came during 15th or 16th century, when people starting in the name of the development, they started cutting trees in thousands. Earlier, it was not possible because earlier they used to have very outdated instruments to cut the trees, and the loss was immaterial. It did not matter. But since the machine age has come, everything has been very bad in the sense that they can destroy anything. They can destroy even the whole lot of jungles and whole lot of rivers. They can all destroy. And in the present age, therefore, it is our duty, the duty of all scientists, to come up with the ideas as to how to solve these problems, that the rivers are free of pollution, our atmosphere remains neat and clean, plants and trees they remain much more as they are required. So these things, they have to be tackled in terms of the science as well as technology. So this has been a wonderful webinar, and I congratulate everybody involved in this. So with these words, I conclude my remarks. Thank you very much.
Thank you. Thank you so much. I would just like to share, I'm tempted, the whole chat box is full for the appreciation of the talks by Dr. Tiwari and Dr. Professor Pradeep, and about the organization of this particular webinar. They are all appreciating, and this is the chat box is full. I don't want to take the names from there, but just want to share that this webinar was liked by so many people. So if the president permits, then we can close this.
Certainly. We can.
Thank you, sir.
Thank you.
Thank you, sir. Thank you very much. And